Hello everyone, welcome to this week's system seminar. And today we have Dr. Jingzheng Ren presenting for us. Dr. Ren is currently an associate professor at the Hong Kong Polytechnic University. He has been selected as the only winner of the 2022 Asia Pacific Economic Cooperation Science Prize for innovation, research, and education in recognition of his scientific contribution commitment to excellence in innovation to achieve economic, environmental, and social goals and biocircular green economy. His research focuses on process systems engineering for energy, environment, and sustainability. He has specialized in developing innovative industrial processes, decision-making tools, and optimization models based on systems thinking to achieve sustainable and carbon-neutral industrial systems for promoting sustainability transitions. He has more than 270 publications, including 210 journal papers, 1 author book, 21 edited books, more than 40 book chapters, and 5 editorials. Since 2020, he has been placed as the top 10 authors in both sustainability and sustainability assessment all over the world based on the total number of journal articles, and he's also ranked in the top 2% of scientists listed in the Stanford List in the field of energy from 2020 to 2022. And Professor Ren, you may begin whenever you're ready.
Okay, thank you. Thank you for the nice presentation. Okay, also thank you for Professor Yu to give me such a good opportunity to share some of our work about sustainability assessment, sustainability improvement, and also sustainability-oriented design and optimization. Just like currently I'm working in the Hong Kong Polytechnic University. Today, my talk mainly focuses on about modeling for sustainability transition. Okay, I will propose some. I will deliver some general models for decision supporting, especially to achieve sustainability assessment and also sustainability improvement and also sustainability oriented design and optimization. Firstly, please allow me to briefly introduce the typical work what we have done. Okay, actually, our work can be divided into 2 parts. The first part is about we have used system thinking to promote sustainable demand, especially about sustainability-oriented assessment and also decision-making, and as well as sustainability-oriented design and optimization. We aim to develop some innovative models to achieve sustainability-oriented assessment, analysis, decision-making, design, and optimization to achieve the economic, environmental, and social goals simultaneously, to promote harmonious development of economy, environment, and society simultaneously. The second part, we have developed some innovative process for converting the waste into wealth or energy, especially to some high value added products. Currently, we are working on developing some to use the so-called zero waste concept and also carbon neutrality to develop the carbon neutral and zero waste process to achieve waste to energy or waste to wealth. We aim to turn waste into value-added product in environmentally friendly and cost-effective and process with high social stability. So what is system thinking for sustainability transition? Actually, for my work, I was deeply influenced by an ancient Chinese philosophy, Zhuangzi. He had ever said, heaven and the earth live together with me, and the mirrored things and I are one. Actually, here, heaven and the earth, in my mind, I think it represents the nature. Me here represent human, and also the mirrored things represent all human activities, especially the industrial process. And also, this word taught me how to promote sustainability transition and how to handle the relationship between nature, human, and industrial processes. So we should recognize nature, industrial process, and human as a whole to promote sustainability transition. Similarly, in our work, we have recognized economy, environmental, society as a whole, and they are one. And also, we aim to develop some innovative process to incorporate economic, environmental, and social goals. These are the 3 main pillars of Scientific. Of course, in our work, we also consider multiple objectives, multiple stakeholders, and also multiple integration. And for the multiple objective, we will consider all the 3 pillars of Scientific: content, economic, environmental, and social aspects. All the 3 pillars of Scientific. And for the multi-stakeholders, we think that in the promotion or in the process of promoting some demand, we need to consider the preference, the willingness, and of different stakeholders, because different stakeholders or decision makers, they may have different preference. Meanwhile, we think that for different criteria for Scientific assessment, for instance, the criteria in economic, environmental, social impact, also in technical impact, they may influence each other. They are not independent. So based on develop the so-called Scientific-oriented decision-making model with the condition of different kind of conditions, for instance, on the uncertainty, on the incomplete information, and also on the hybrid information, we aim to achieve the so-called smart decision-making and also policy-making to promote Scientific transition. And another fact is about we would like to make the matter touch to be a truth by developing innovative process to turn waste to wealth. Especially, we are trying to incorporate industrial symbiosis and the concept of zero waste and carbon neutrality in process design to achieve 100% waste recycling. Also, in the process optimization, we would like to incorporate all the Scientific goals. We'd like to mapping, for instance, all the UN summer demand goals with in process design process to achieve green economy, circular economy, and also bioeconomy simultaneously. So in summary, our work can be divided into two aspects. The first aspect is about assessment and also decision making. Then another aspect is about optimization and design and optimization. And for the first aspect, we have developed a complete system for life cycle Scientific assessment and also decision making with the condition of different kind of conditions, just like I've mentioned before, with the consideration of different kind of stakeholders, with the condition of under the condition of uncertainties and also incomplete information and hybrid information. And for the second aspect, we have achieved, we would like to develop some model to achieve point optimization, line optimization, and plan optimization to achieve Scientific transition at different levels and different scales. Then finally, we aim to develop Scientific assessment, analysis, design, optimization, and design tools with the condition of the preference, willingness of different kind of stakeholders at different scales, and also with the condition of different objectives, and also under different scenarios to promote the Scientific transition. Okay, and for the first part about Scientific assessment and also analysis, we know if we would like to achieve Scientific assessment, we usually need to consider 3 aspects, namely economic prosperity, environmental cleanliness, and also social accessibility. So we first you need to determine if there's an industrial process, we need to determine the performance of the process with respect to different Scientific pillars. How about its performance with respect to economic, environmental, and social impact, then to assessment. If there are different processes, we can firstly determine the Scientific performance, then to use multi-criteria decision-making tool to make a decision, to help the stakeholder to make informed decision to choose the most suitable alternative among different processes according to the willingness and preference. So we have developed different tools about Scientific assessment by using multiple decision-making method from life cycle perspective. When knowing all the information on uncertainty and considering the interdependence and interaction among different Scientific criteria. And also, last one, we would like to achieve Scientific-oriented decision-making on the on the uncertainty and also hybrid information and also incomplete information. And for the first aspect about stability assessment, if we would like to find out if we have developed a new process to find out to convert the waste to wealth or some other industrial process, if we would like to know its stability performance, we usually need to know how about its performance with respect to economic stability, environmental stability, and also social stability. Usually, firstly, we can, for the new process, we can use different commercial simulation tools to simulate the process to determine the performance at process scale. For this one, we have developed a process about how to convert the COS sludge into methanol, including gasification, power generation, and different sub-processes. We can firstly use front-end adjustment plot to get its performance with respect to economic, environmental, and social aspect. Firstly, to achieve front-end, if there may be different alternative processes front-end to achieve our goal. For if we would like to produce hydrogen, we may have different kind of alternative processes for hydrogen production. For example, coal gasification, biomass gasification, and also water electrolysis based on solar power or wind power. We have different choice. We have different alternatives. We need to identify among all these alternatives, for example, coal gasification, biomass gasification, water electrolysis based on solar power. So which one is the most sustainable? Firstly, we need to determine how bad its stability performance. Then after that, we can make a decision which one is the best according to the preference and also the stakeholder, the preference and willingness of different stakeholders. And for the data collection, we I mentioned before, we can of course use different commercial tools to simulate the process to collect some data. We can also collect data from field survey and also from public report and also literature review. We can use combine LC, LCC, and SLC to achieve life cycle stability assessment. LC, namely life cycle assessment, to assess the comprehensive environmental performance of the process. LCC, life cycle costing, to assess the comprehensive economic performance of process. Social life cycle assessment, to assess how about the social performance of a different process. And usually in stability assessment, we know economic, environmental, and social are the three pillars of stability, but we also need to consider from technical aspect. Why? Because sometimes any efficiency, all the safety status and also the risk of process will have significant impact on environmental or economic aspect. After that, we can determine the criteria system. We know that there may be different economic criteria, environmental and also social criteria. There may be for different kind of stakeholders, they may have different importance, relative importance. So we first need to use different tools to determine the relative weights, namely its relative importance of different criteria. Then we can use the multi-criteria decision-making method to rank the process. So this is a life cycle stability-oriented process selection framework. Firstly, we determine what are the alternatives, then to collect the basic data, then to have a comprehensive life cycle, economic, environmental, and social performance, then to determine the decision-making metric, to then finally determine the priority order of all this process. For the COS sludge valorization process, we may have different processes that can convert COS sludge into high value-added product. For the AD process, incineration with power generation, gasification, and supercritical water gasification. Of course, all these processes can convert COS sludge into wealth, into value-added products. So we would like to know which one is the most sample. So usually we need, in this kind of decision-making problem, we usually need face several challenges. For instance, there are different processes. And also they may have different performance in economic, environmental, and social impact. For the one process A may perform better in one aspect, but may perform worse in another aspect. Similarly, it's process B may perform well better in another aspect, but perform well in the other aspect. So it's difficult for the stakeholder to know which one is the most sound process. We first need to have comprehensive sum-beta assessment on all these processes to determine, just like we have mentioned, I have mentioned, okay. Firstly, of course, we can collect all the data through simulation, through field survey, or from the published work to get all the related data of all the process with respect to economic, environmental, and social criteria. Then to determine the decision-making matrix. Okay, and for this one, we can combine LC, LC, and SLC to achieve this. So this is if we know all the information, we can make such decision. It's very easy for us to achieve. Firstly, we simulate the process or collect the data through some other way. We can get all the data, and also it's easy for us to establish the decision-making matrix. Then based on some general decision-making matrix, we can make such a decision. But sometimes we need to point out that usually in the decision-making process, we usually face several some other challenge. For instance, the vagueness and ambiguity and subjectivity in human judgment, okay, especially in the process of determining the weights of the submitted criteria. There may be, for instance, the life cycle cost and also global warming potential. Firstly, we need to ask the stakeholder to determine which one, how about its relative weight and namely its relative importance. We usually ask the human to judge, for instance, how about criteria 1 compare with criteria B, criteria 2. The second one compare with the first one compare with the second one. Maybe we need to ask the stakeholder and the decision maker to use the linguistic term. For instance, the traditional method, especially about AHP, analytic hierarchy process. We know all the AHP method, we usually ask the stakeholder to use the word similar like this. For instance, A compared with B is significantly important or moderately important or similar this kind of word. And also the moderately important, significantly important, they are usually compounded to different question numbers from 1 to 9. Usually in it's very difficult for human to use exact number to describe the relative importance compared with A and B. So the so-called vagueness ambiguity. So how to solve the problem? And this is the weakness of the traditional decision-making method for an HP and also the best-worst method. Here we would like to promote the traditional weighting method into interval condition. For instance, A compared with B, we can use the word between moderately important to significantly important. So we can transfer this can to some extent can solve the problem existing in human judgment. In addition, we usually face some data uncertainty problems. So accordingly, we have developed some multi-criteria decision-making process based on interval number. And also we can ask stakeholder to use interval number to compare different criteria to solve the problem of vagueness, ambiguity, and subjectivity existing in human judgments. And meanwhile, in the decision-making matrix, we also allow them to use interval number to represent the relative performance of different alternatives with respect to economic, environmental, and social criteria. Okay, this is and based on this way, the process existing, the challenge what we have mentioned can be solved. And also we have also developed some multi-actor, multi-criteria decision-making method. We know that for process, for the selection, it usually involves different kind of stakeholder, the government, the investor, and also engineer and NGO, and also some other packs. They may have different preference and weakness. And we can consider how to incorporate all these weakness, all these preference and also willingness into a composite weight for each criteria to solve this problem. Okay, last one we have mentioned. For most of the traditional methods in the decision-making process for selecting the most sample process among different alternatives, they usually recognize sometimes the economic criteria, environmental criteria, and the social criteria as independent, but actually not. Sometimes they will interact and also influence each other, just like we have mentioned at the beginning of our talk. For the energy efficiency, if we can improve the energy efficiency, it is helpful to mitigate the global warming potential or to mitigate the carbon dioxide emission. It can also improve the economic profit. So we also need to, in some process, we also need to consider the interaction and also interdependence among different criteria for somebody assessment. Similarly, we also incorporate to extend the traditional weighting method into the one which can incorporate the interaction and interdependence among the criteria. But we also need to admit that all these are also still based on human judgment according to appearance. So another big problem is that we need to answer is how to quantify the so-called soft criteria, for instance, that cannot be quantified directly. For instance, the social acceptability. How to do that? Usually, for our work, we use a fuzzy inference system to quantify the soft criteria. So in which in the whole sampling process, we consider both hard criteria that can be quantified directly and also the soft criteria that cannot be directly quantified in the decision-making process to ensure that, okay, we can build a complete enough criteria system to achieve object-oriented decision-making. It means that, okay, in the decision-making process, we can build a complete enough criteria system according to the willingness and preference of the stakeholders to help them to determine the best or the most process according to their own willingness. But in the decision-making process, we need to point out that maybe for difficult process, for the A, B, C, D, process A, process B, process C, and process D, maybe for different stakeholders, they may choose different process. So our we aim to develop the special decision-making framework to help them to determine the most sample according to their own willingness. Similarly, we also incorporate the game theory approach in the decision-making process to achieve mutual agreement. And also the last one about decision-making, we have mentioned sometimes we need to make a decision on the incomplete information. It means that we know some data of the process, but we also don't know the data of the process with respect to, for instance, economic impact or with respect to technical impact. So how to make such decision in this process? We have introduced the damped and shape model, especially the evidence theory in the decision-making process to successfully solve this problem, to achieve life cycle stability-oriented multi-criteria decision-making on the incomplete information. It means that even if we cannot establish a complete decision-making matrix, we can also make a decision for the stakeholder. So all the last one is about how to make a decision, multi-criteria decision-making on the hybrid information. So what does hybrid mean? It means that usually in the decision-making matrix, all the data are crisp numbered, but we know sometimes the preference of the process with respect to some criteria for the economic aspect, especially life cycle cost for the production for the hydrogen. With the change of the market, the price will change with time. So we need to consider maybe the total cost belongs to an interval or it is stochastic. So how to make such a decision? In this process, we have developed the multi-criteria decision-making on the hybrid information, in which the decision-making metrics were composed by the data, including CRISP number and also the interval number and also the fuzzy number, to have the stakeholder to make such a decision. And for the second part, we have developed the point line plan lifecycle sustainability-oriented design and optimization model to achieve sustainability-oriented design and optimization at the process level, lifecycle perspective, lifecycle level, and also the supply chain level. And for the first one, point optimization, counted most of the method about process design or optimization that focus on mainly about economic impact. Some may consider about the sometimes both economic or environmental, both economic and also environmental objective. But in our work, we would like to incorporate all the sustainability good in the design process. For now, in this one, in this process, if we would like to determine the best operating condition, we would like to achieve sample process design. We consider economic, environmental, and also economic, environmental, technical, and social aspects simultaneously. For the economic aspect, we consider different economic indicator objective. For the environmental aspect, we consider different environmental objective, and for the technical aspect, we may consider front-end energy efficiency or energy efficiency. And for the second social aspect, we may consider front-end is safety, all the risk of process, all the created jobs by launching this process. We aggregate all this sustainability goal into a composite sustainability goal and to optimize the process. And according to our study, to some entire process, it can help to reduce the total cost and also reduce carbon dioxide emission. So this is about the point optimization. Currently, we are also working on how to link, how to mapping all these 17 United Nations sample demand goals in the with the sustainability indicator to incorporate, to do our best to incorporate as much as possible of the UN's sample demand goals in the process, process design and the optimization process. And for the line optimization, we have developed both some qualitative and quantitative methods for life cycle sustainability improvement and of industrial system. And for the quantitative approach, we have combined life cycle thinking with different kind of models. Okay, we may have sometimes in a process of for system optimization, especially about sustainability oriented optimization, we may consider different kind of sustainability goals, and we may demand different parallel solutions. It means that different operating conditions for such a system. Then we recognize each one as a decision-making unit, and we combine the data envelope analysis to analyze all these parallel solutions to identify the bottleneck and consider, then we can know how to improve the process. So this is the quantitative method, and for the quantitative method, we have incorporated sometimes we to investigate the process or the system or the whole supply chain from the macro perspective. Sometimes they may be different factors or different aspects that will, different criteria that will influence the total sustainability. Sometimes we would like to take the biofuel industry as an example. There may be different indicator, different criteria that will influence the overall sustainability performance of the whole industry. And all this can be divided into two groups, including the coded group and also the effect group. The coded are the net coded that will influence the total sustainability. So we will first use sometimes to extend the demetal method into, for example, fuzzy demetal or gray demetal method to divide all these factors into cause group and also effect group, then to identify what are the most important factors in the cause group. Then we will know how we can take effective corresponding measure or countermeasure to improve its submitted performance. Similarly, we also develop some other quantitative methods by combine. Some other methods by combine both quantitative and also qualitative methods based on some tools belong to operation methods, just like we mentioned for the best worst network method, AIP, and also with the ISM method to identify what are the most influential factors that will influence a system. And for the last one, plan optimization, we aim to develop different scientific-oriented optimization tools to achieve scientific-oriented design of the whole system from the perspective of supply network. We have combined the traditional life cycle thinking, for example, with image, with also ecological footprint, and also interval and civil structure model to achieve scientific-oriented design. We would like to use a very simple supply chain for slide valorization as an example to show our work. In our work, we introduce the concept of circular economy and industrial symbiosis in process design. For different subsystems, its waste may be used as feedstock in another subsystem. So we consider all this as a whole. This is the so-called industrial symbiosis. It means that, okay, if for a system, there may be some waste, including for carbon dioxide emission. It may be used as a feedstock in another process. This is so to achieve carbon utilization. Similarly, for some other waste, it can also be used in other process to achieve industrial symbiosis. And our final goal to achieve almost 100% waste recycling to achieve almost zero waste in the whole system optimization process. So, we usually, if we want to promote some basic transition, we need to, I think that we need to investigate the performance of different systems at process level, at life cycle level, and also at supply chain level, or even at regional level. And for the process level, we can consider different alternatives. For example, we'd like to use the biomass, especially kind of we are working on the COS slide, and also some for instance the waste straw as an example. How there may be different process to convert from a polyether or some other biomass into waste or high value-added product. We can firstly through process simulation and also process optimization to achieve to determine the most time process for each alternative. After that, we can have life cycle scientific assessment on each process, then to determine the best process for the best alternative. Then after that, we can consider how we can achieve sample supply chain modeling to also determine the carbon neutral or sample supply chain at the regional level or from the perspective of supply chain. The last one, I would like to share some of my idea about how to achieve some scientific decision making for scientific transition. I have proposed a multi-X framework for scientific-oriented decisions. I think that in scientific transition in the process, especially in the decision-making process, we usually need to consider different stakeholders. Because just like we mentioned before, different stakeholders may have different willingness and different preference. especially including the investor, government, NGO users, or readers. Okay, for if we would like to develop a process or to launch a process for convert waste to wealth or to energy. Okay, we would like to use MSW as an example. If there may be different process, they may have different economic, environmental, social impact, and also some other influence, no matter the positive or negative impact on the whole society, on the community. If we only consider preference of specific stakeholder, it cannot represent. In the decision-making process, it is not group decision-making. So we may consider to use decision-making method to make such a decision for submitted transition. Second pack, we have mentioned we need to consider different dimensions, just like I mentioned before. Usually in the traditional work, we usually consider only 3 pillars: economic, environmental, and social impact. We think that all these are the 3 pillars of sustainability. But actually, the criteria in some other impact will also influence the sustainability performance. Just like we mentioned, okay, funding efficiency will influence economic and also environmental aspect. Similarly, some other factors in social or political and cultural dimension, it may also influence the 3 main pillars of sustainability, namely economic, environmental, and social pillars. So we need to determine multiple dimensional decision-making or sustainability process for the stakeholder according to their preference to reflect the true sustainability performance of different processes. Then in the process of achieve sustainability, we may need to consider achieve sustainability transition or to promote carbon neutrality at different level, at regional level, provincial level, and also national level. Like I mentioned, okay, for we know the hydrogen fuel vehicle may be sustainable, or the electronic vehicle may be sustainable. It may be beneficial to achieve sustainability transition or achieve carbon neutrality. But we would like to answer, how about where does the hydrogen come from? Does it come from coal, from traditional method, or from biomass gasification based on some renewable energy? So the result will be different. Similarly, for the electronic vehicle, how about where do the battery have been? Where do the battery produced? Where has the battery been produced? It may also influence the result. It may achieve to a kind of pollution transfer. If we cannot investigate sustainability performance in a comprehensive way at different levels. Meanwhile, we also need to point out sustainability at process scale may not mean a better sustainability performance at the life cycle level or at the supply chain level. The last one, if we want to achieve sustainability transition or achieve carbon neutrality, we may need to consider to achieve this goal based on different pathways, including sometimes we can use different renewable energy source, different waste to energy process, and also by the incorporate of DS and also some carbon capture, storage, and utilization process. This is so-called how we can recognize all this as a whole to achieve industrial symbiosis to solve the problem from system thinking. Last one, we may also need to consider how about its influence at different sectors for different fields. So this is the what I want to share today about how to use decision-making tool to achieve sustainability. Then last, I would like to summarize what I want to deliver today. And today I do not present the exact method or model we have used for decision-making of our sustainability assessment. And for sustainability transition, I think that firstly, we need to know its sustainability performance. So we need to have a comprehensive sustainability assessment. And for comprehensive assessment, we need to know how about its performance with respect to economic, environmental, and social sustainability. Meanwhile, we need to consider some other factors belong to some other factors, technical effect, how they influence, how this factor will influence economic, environmental, and social impact. And for sustainability-oriented decision making, we also need to face different challenges. For instance, how about data uncertainty? How to make decisions on the incomplete information or on hybrid information. Then last one, we would like to say that, okay, currently most of our work focuses on but sustainability-oriented optimization at the process level. But even a process is sustainable, it does not mean that, okay, the product manufactured in this process is sustainable. So we need to incorporate it at the life cycle level. But at the life cycle level, we also need to consider how about its influence at the regional level or at some other big level. How about the performance? So this is all what I want to deliver today.
Thank you so much, Professor Ren, for presenting for us, and we look forward to the next system seminar. Thank you.
Okay, thank you.
Thank you, Professor Ren.
Thank you, bye-bye.
Bye.
Thank you, bye-bye, bye-bye.